Well, to be honest, as an astronomer, I don't like clouds so far.
It looked crazy. It was like a crazy ocean. And I went, that's the same cloud again. And then I started seeing them everywhere. What's the name of this cloud? I mean, why? Why is there a hexagon on Saturn? I don't know the answer.
But still, we do not understand exactly the origin of this hexagonal-shaped cloud. 여러분 안녕하세요. 네, 오늘 굉장히 구름한 아주 예쁜 공간에서 인사를 드립니다. 저도 특별하게 구름 옷을 입고 왔는데요. 오늘 좀 굉장히 떨립니다. 제가 어렸을 때부터 팬이었던 분을 직접 만나는 진정한 성덕이 되는 시간이기 때문에 오늘 여러분들과 아주 특별한 인터뷰를 한번 진행해 보도록 하겠습니다. Okay, so we all have one special thing that we most like. For example, in my case, I like galaxies and I study and I love them. So today we will meet a gentleman from UK who had fallen in love with the cloud. So welcome, Gavin.
Thank you. Thank you very
nice
much,
to meet
Mr. Dust.
Well, to be honest, I was thrilled when I heard that I will be interviewed with you because since I was very young, I was a big fan of you. So today I brought some of your books here. For example, the first edition and revised edition of your The Cloud Spotter Guide, and also more recently published book, A Cloud a Day here. Yeah, so I will ask you for autograph after today's shoot.
I would love to. I would love to autograph.
Yeah, also, if you fell in love with the clouds after today's interview, I highly recommend reading this book. Could you please introduce about yourself to our viewers?
My name is Gavin Frito-Pinney, and I'm member number 1 of the Cloud Appreciation Society, which I started 18 years ago. It is a society for people who love clouds. So far, we've had 63,000 people join. They all come from different cultures, but they all have a shared idea that the sky is one of the most beautiful parts of nature, and that clouds are a part of nature that emotional, maybe poetic, the most poetic part of nature. They are nature's abstract.
Well, to be honest, as an astronomer, I don't like clouds so far because when the sky is cloudy, I can't see stars. So when I heard about you first time, I think it's very interesting that clouds that I dislike can be a source of love for someone else like you. So can you explain which point, what made you fall in love with the cloud exactly?
Yes, I understand your frustration because the stars are the part of the sky that is reliable, always in the right place, and the clouds are chaos. They are the opposite of the stars. You have to embrace the dance of water in our atmosphere. It will appear, it will disappear, and we cannot control it. This is difficult for humans.
Yes, that's right.
It is difficult for humans to accept that we have no control.
I think the cloud is one of the mysterious and also most chaotic phenomenon in our sky. And also the cloud is one of the most common phenomenon. But it's very interesting. We still do not fully understand about them. So now, could you please explain the basic physical process of formation of cloud in our daily sky?
Clouds are made of water.
Okay.
All right, number 1.
Okay.
And the low clouds are made of liquid water, tiny droplets. The high clouds made of ice crystals. So we have liquid water and solid water. But our atmosphere, like here in the room, also has water, the gas form of water. This is called water vapor. And water, it is the only substance that is present naturally in solid, liquid, and gas. No other substance. This makes water very special for our planet, and it's why clouds are special, because clouds can appear and then disappear. The way that a cloud appears is when the moisture, that is the gas form, like in every breath we breathe out, there's gas form of water, when that decides to change into a liquid, droplets or ice crystals. To make that happen, you need a few ingredients. One is you need some little atmospheric aerosols, tiny little particles.
Yes.
And they can be dust, smoke from fire, pollution, or they can be salt or from the ocean. They are an essential ingredient for clouds because when the air cools, the moisture can want to change from a gas to a liquid or to solid, and they get started, and you get lots of tiny water droplets begin to form on these little particles in the atmosphere. And then, when it was invisible, they can get a sudden change to be lots of droplets. And when you have lots and lots of droplets in a part of the sky, it looks white, because anything with lots of surfaces looks white. It's why a wave, when it's breaking, it looks white because of all the bubbles. Or when you see snow, it looks white because of all the surfaces.
Then how about just dark cloud in rainy days?
Okay, good question. Why do they sometimes look dark? So when you see a dark cloud, you know instinctively, you know there's possible of rain. And this is because a dark base of a cloud happens when the cloud is tall. When a cloud is tall, the sunlight coming from above cannot reach the base because it's bounced off all the particles. So by the time it gets to the base, not much light is coming through.
Lack of sunlight.
Lack of sunlight.
Yeah.
And when we are looking, our eyes see this lack of sunlight underneath compared to bright sky elsewhere, and we know that it looks dark. This is because it's tall, and whenever a cloud is tall, it is likely to produce rain.
What is your memorable experience about clouds to date?
Oh, well, I think one of the most memorable was when just before I started the Cloud Appreciation Society.
Really? Yeah.
Yes. And I went to Australia to see a cloud. So that is a long way from the UK, opposite side of the world. I went to Australia to see one particular cloud, and it's called the Morning Glory Cloud.
Morning Glory Cloud. Beautiful name.
Yeah, and it is a famous cloud in Australia. This is it here. Yes, it is a famous cloud because it is like the cloud to surf on. You know surfing on the ocean?
That's right.
This is the atmospheric equivalent because this cloud forms in a wave of air, a traveling wave of air. And at the front of the cloud, the air is lifting, and at the back of the cloud, the air is sinking, and the cloud itself is rotating as it travels. It's known as a roll cloud. This is the general name for it, or volutus.
Volutus.
Volutus is the official classification. And the Morning Glory is an example of this cloud that forms in northern Queensland in Australia at a certain time of year, the end of September, beginning of October. This is springtime in this region, and that is when glider pilots rush to this tiny town in northern Queensland called Burketown. Burketown is tiny, only maybe 180 people live there.
Okay.
But this time of year, glider pilots all come there because they want to surf this cloud. And they go up in their planes and they get to the front part of the cloud where the air is lifting, and they can travel all the way down the length. It is a very long cloud, maybe 900 kilometers long, but they can travel down the length of it, turn around and come back just like a regular surfer on an ocean wave. As the wave travels, they stay at the front, and the cloud shows them where the air is lifting at the front. So I went and saw this, and it was an amazing experience. I went up in a little Cessna aircraft because I don't know how to fly. I went up and I filmed and photographed the glider pilots as they were surfing the cloud. It was amazing.
Is it possible to see them only in Australia?
No, it is possible to see this type of cloud in other parts of the world. You'll see them here in Korea.
Oh, really?
But the difference is there, it's a regular time of year. You're quite almost guaranteed to see the cloud. If you're maybe 2 weeks in this place at this time of year, then you are very likely to see it. And it's also particularly long and particularly big example. But no, you can see these clouds in Korea. Mostly they will form in coastal regions. So in coastal waters, the interaction between the wind from the land and the wind from from the sea can cause this roll of cloud. So if you're looking for one here, you've got to be looking in the coastal waters, not inland.
Okay, so now I want to give you some experiments.
Ah, yes, I love experiments.
To be honest, I'm an astronomer, so
Yeah.
I'm not expert to experiment. Okay, but I will try. As you explained, according to the basic physics process, we can reproduce our own cloud in plastic bottle. So I have prepared some tools.
Oh, well done. Oh, this is great.
Here, the
Okay.
plastic bottle.
Here, you got your bottle.
And this is hot water.
Hot water,
Yeah.
okay.
First, let's fill this bottle with this hot water.
So you have to make the air inside that bottle
Yeah.
saturated.
Yes, that's right. And then I will light a match and
Right.
put this inside this bottle. Please do try this at your home. It's not danger. Okay. It
Now that-
will reduce the air pressure inside
Right.
and close this bottle's mouth rapidly. The air pressure inside is slightly lower than the outside, the room pressure. Now I will squeeze this bottle and make the pressure inside higher.
High pressure.
Yeah. And now let's see what happened. Wow!
Wow!
Cloud. White
Yeah,
cloud.
couldn't they see that?
Yeah. Again, when I release my hand,
Yeah, perfect. It's foggy.
then the air pressure inside is rapidly decreases.
Yes.
So without strong energy transfer, as the volume increases and pressure decreases, then this process make the vapor condense into water droplet rapidly.
Yes.
Yeah, so we can see a kind of formation of white cloud in this bottle.
And also, when you put the match in, you also introduced some smoke particles. And those are important
Aerosol.
ingredients. So the same thing happens outside, but usually this change in pressure that you did in the bottle, this happens by air rising. Because our atmosphere is like an ocean, down at the surface where we live is the highest pressure. Pressure here. But as soon as air lifts, it expands. Pressure gets less. And when it expands, the air cools. And when the air cools, this can happen. So that's precisely what happens daily when a cloud forms. It's beautiful.
Thank you. To be honest, this is exactly the first experiment ever I did.
Really?
We call this phenomenon as adiabatic expansion. So this is the basic process of cloud formation. Well, I had done some research about you. In 2009, you have discovered a new type of cloud called asperitas and proposed as its official new types of cloud. So I didn't expect that there are still more cloud types that waiting for be discovered. So could you please explain the new types of cloud asperitas?
So I was sent a photograph in 2008 of a sky. It looked crazy. It was like a crazy ocean, like you're looking up at the surface of the sea on a really stormy day, if you were snorkeling under the water and looking up. And so it had waves going like this. And every time someone sends a photograph into the Cloud Appreciation Society, we put it on our photo gallery and we say what cloud type it is. We categorize it. This one, I was like, that's unusual. I don't know what classification of cloud this should be, but I didn't think more about it. I just like, okay, whatever. And then maybe a few months later, someone else sent one. I went, that's the same cloud again, but I don't know what to call. And then I started seeing them everywhere. The first one came from the United States in Iowa, and then someone sent one from Australia, someone sent one from Greenland, all over the world. And each time I would go, there's another example of this cloud. And then I thought, what's the name of this cloud? And then I thought, it doesn't have a name. And then I thought, it needs a name. And so that was the beginning of a journey to find a new classification of cloud. And what happened was I called up the Royal Meteorological Society in the UK. I said, I've got a new cloud. And they said, yeah, right. Let's see your new cloud. And so I went in, I showed them some pictures that members of the society had sent, and I had a name because I asked my cousin, who is a Latin teacher, I said, what's a good name for a Latin word for a cloud that looks like a crazy sea? And he said, do something with the Latin verb aspero, which means roughen. And it was used when they talked about the sea, the Romans. So it ended up being called asperitas. And the World Meteorological Organization are the people who decide on the classification system. And they have a book called the International Cloud Atlas. It was first published in 1896. And every 20 years or 30 years, they do a new edition of this book. And the people in the UK said, the World Meteorological Organization will never do a new edition of the book for your cloud. If it is not in that book, it is not official. But it is funny because the public learned about this and it became a kind of viral news story. And then the WMO, the World Meteorological Organization, decided we will do a new edition of the International Cloud Atlas and we will make this a new official classification. And it was the first new classification since 1951. And it was all because of members of the society around the world. They have an eye on the sky. They have a smartphone in their pocket and they know where to send their photo.
Do you think there might be some more new types of clouds hidden somewhere on Earth?
Well, I think there is another formation that we would like to be made official, and it looks like eyebrows. And this cloud formation looks like lots of eyebrows.
Oh.
And you sometimes see it when there's a mountain that is a steep mountain and the wind comes over and forms a wave. There are many cloud formations that form in this wave, but sometimes the wave breaks. There is where you can sometimes see these eyebrow-shaped clouds. And so I think this doesn't have a name, and we think they should be called supercilium, which means eyebrow in Latin. But I don't think the World Meteorological Organization will be doing another edition of the book for 20 years. So maybe we have to wait.
Okay, they have a very heavy rain in Seoul now, so we have prepared some intriguing picture of peculiar cloud for you.
Are these all in Seoul? Wow.
Yeah, so it looks like there is a huge hole in the sky and there's a raindrops only within a very specific narrow region.
Yes.
Do you have any idea to explain this phenomenon?
So this is called a microburst.
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 Okay.
And it is when a storm cloud produces a very localized and very sudden and heavy downpour. So this cloud at the top, which we see the base of, is a cumulonimbus. This is the mighty storm cloud. Big, it spreads out at the top like an enormous mushroom. So it spreads out at the top. This storm cloud produces heavy showers, but sometimes the shower is very localized and very discrete. And this microburst happens when the air in the precipitation gets suddenly cold, and colder air is heavier. And the reason why it gets cold is not 100% clear, but often it seems to be to do with evaporation of droplets, because as you know from physics, when a droplet evaporates, it takes the latent heat away and you end up getting the air colder. The opposite normally happens in a cloud. When droplets condense, then they get warmer, and this adds to clouds growing. This is the opposite. When some of the moisture in the cloud maybe melts from ice to water, or maybe some of it evaporates, you get a sudden cooling in one part of the cloud. And that sudden cooling, when you add up lots and lots and lots and lots of droplets or ice crystals melting, you get a sudden cold region of the cloud, and that sinks very fast. And this microburst can happen with rain like this, or it can happen a dry one.
Oh, really?
You can't see. That's because all those droplets have evaporated away, but it's made the air very cold in one region, and it sinks, even though there's no rain. Both of these are dangerous for aviation, because when this air reaches the surface, it goes whoosh, and so you get sudden air blowing away from the microburst. So if you're in a plane coming in to land, it is an unexpected wind that can cause problems for landing or taking off aircraft.
This sounds very dangerous.
Dangerous, particularly the dry ones, because you can't see where it's happening. And the dry ones are problematic for aviation.
Well, silly question popped in my mind. So when I was young, I sometimes imagined and wondered what would happen if I jumped into the cloud. So is there any specific real case in history of real person who had experience going through the cloud?
Yes, but it wasn't jumping onto the cloud because they wanted to. It was because of an accident. So this was in the 1950s. A US Navy pilot, William Rankin, he was flying his aircraft over the top of storm clouds. So he was in a jet aircraft flying over the top of high cumulonimbus storm clouds, these ones.
Okay.
It's okay if you're in a jet because you can go very high, get over the top of them. Even though those are the tallest of the clouds, you can still go up over the top. It's okay until your engine dies.
Okay.
Which is what happened to William Rankin. He was up there, all the dials on his engine just went doof. All the power went, everything gone, and he was like, couldn't do anything, and he realized that he had no choice but to eject, and he was up at maybe 40,000 feet, something like that, very, very high, and he didn't have any oxygen. He started falling like this, and there was a storm cloud just beneath him. He started falling, tumbling, his stomach expanded because of the air pressure, going like this, and then he remembered going into the top of the cloud as it became like fog, but it was ice, and he couldn't see which way was up. He didn't know what was happening, spinning and spinning and spinning, and he didn't know if his parachute was going to open. And it got darker and darker as he went inside this storm cloud until suddenly his parachute opened, and he thought, I'm safe, it's okay. But then he started hitting the hail. The hail of ice stones started smashing against him inside as he was spinning around, and then the lightning and the thunder happened, and it was like explosions all around him. Not sound, like explosions. He said it was like being trapped in a cage with mad lunatics with bats hitting him.
What a nightmare.
A nightmare. And he eventually came out the bottom of the base of this storm cloud. He emerged and landed in a tree, and I think he'd broken his leg, but nothing bad.
So did he alive?
He's alive.
Wow.
So don't try and sit on a cloud.
Yeah.
This whole story is in my book, The Cloud Spotter's Guide, in the chapter that is about the storm cloud, the cumulonimbus cloud. I give the whole story about William Rankin's adventure of falling through a cloud.
Now let's move on, more scientific issues.
I want to ask you about some of the clouds in space.
Okay.
Can you tell me an interstellar cloud? Is it a cloud?
That's a very nice question. Technically, we define that just cloud because a bunch of particles gather in the same region. So we call that cosmic cloud.
Exactly. And so one needs to expand one's idea of a cloud when you go into space, because we think of clouds of water here on our planet.
Yeah.
But as you probably well know, clouds on other planets not made of water.
That's
necessarily.
right.
On Venus, they're made of sulfuric acid.
Yeah, sulfuric and carbon dioxide gases.
Exactly. Or maybe is it methane on
Titan.
Yes. And then also on Jupiter, there are clouds. They're made of ammonia.
Yeah, ammonia. Yeah. Okay, so I have already read your book, A Cloud a Day, and also in this book you introduce not only cloud on our planet, but some cloud beyond the Earth like this.
Yes.
As you may know, the clouds are not exclusive to Earth. So is there any memorable cloud beyond the Earth so far?
Well, yes, absolutely. The most memorable cloud on the other planets of the Earth, in my opinion, is on Saturn.
Saturn.
Do you know the hexagon of Saturn?
Yeah. Actually, I brought that picture.
Oh,
here.
yeah. Is that amazing?
Yeah.
I mean, why? Why is there a hexagon on Saturn? I don't know the answer. I think it is to do with the jet stream.
That's right.
The jet stream, normally on Earth, the jet stream is changing chaotically, is like a snake going up and down, then it breaks and then it reforms. But on Saturn, it's very, very geometric.
Yeah.
It's like a maths class of geometry. Do we understand Why?
Well, to be honest, some astronomers suppose the origin of this hexagonal-shaped cloud is a combination of jet stream and rotation of Saturn itself. And some of them had tried to reproduce this kind of hexagonal shape in laboratory. But still, we do not understand exactly the origin of this hexagonal-shaped cloud. It's very mysterious.
Isn't that amazing? I mean, it's an example of order emerging from the chaos of clouds. There are so many things we still don't understand about clouds.
And also, I want to introduce a very interesting example of exoplanet you may do not like.
Okay.
So, the WASP 96b is located at 1,200 light years away, and this planet is very famous as a cloudless planet.
Yeah.
So, astronomers have discovered that there's no cloud in the atmosphere of this planet.
So it does have an atmosphere.
Yeah,
Not like Mercury, which has no
Yeah.
atmosphere.
Even it has its own atmospheric system, but we cannot find any evidence of the existence of cloud.
I'm not moving there. Well, I mean, in this book, A Cloud a Day, I do talk about some of the clouds on other planets. So many of these are photographs sent in by our members around the world, and we write a short explanation each day, 365. Here you can just pick a page, read it, and then pick a page, read it. You don't read it all the way through.
Like a diary.
Like a diary.
I heard that you recently published a new book.
Right. Well, this book is called Cloud Spotting for Beginners. And this book is illustrated. And it is an introduction to spotting clouds so that you can learn the different classifications, but do so in a way that's simple and easy to understand. And the best way to learn about clouds.
As I mentioned at the beginning of today's interview, as an astronomer, I do not have positive feeling about the clouds. But after today, I can say that here comes one more cloud enthusiast.
Yay! We now have Mr. Dust in the Cloud Society.
Yeah.
Well, I mean, I've loved doing this interview. It's really fascinating to try and convince an astronomer to like clouds.
Okay.
I love the challenge.
And also, I have prepared special present for you. I'm not sure whether you like this. Could you please open?
Wow, thank you very much. That is amazing. Where did you get that? I've never seen anything like it. Look at that. How do I look?
Finally, you became the ultimate cloudy guy. I was really glad to see you today, and I hope more people fall in love with a cloud like you. Thank you.
Thank you, Mr. Dust.